Okay, in this video we're going to look at how to graph an exponential function. So just to recap what you just read about, y equals ab to the x, that's an exponential equation because there's an x in the exponent. Okay, so that's the key. That's how you know you have an exponential equation. X is in the exponent. Exponential functions do have a special feature to them. They have these things called asymptotes, and those are lines that your exponential is going to get really close to but not actually touch or cross. So it kind of helps guide the boundaries for your end behavior. So in this case, the one that you just wrote down, y equals 2 to the x, this would be considered exponential growth. Couple ways I can tell that. I can tell that because this red exponential equation is increasing. I can also tell from the table because again those y values are increasing. I can tell from the 2. Anytime that b value is greater than 1, it will be exponential growth. Okay? The other thing I want to talk about is some of those key features. So on an exponential equation, the domain will be negative infinity to infinity. I can tell that a couple ways. Number one, if I look at the red graph, the exponential curve, I can tell that it's going to continue from the negative infinity sign and it's going to keep increasing to the positive infinity sign. I can also look at the equation and say, you know, what kind of values could I substitute in there for x? Well, I could substitute in positives, I could do negatives, I could do fractions, decimals. I really could substitute anything I want in as an exponent. Okay, so that's why my domain is negative infinity to infinity. Now the range, the answers I get out, if I look at this table, if I keep decreasing my x values, my y values are just going to keep getting smaller but never ever negative. They don't ever get to a negative amount. There's nothing I can stick in for x that would give me a negative answer. You might think if you stick in a negative exponent you get a negative answer, but negative exponents actually just do the reciprocal and make the number smaller. Okay, I can tell that from this graph that as that graph kind of came down here, it's leveling off at 0. So my range will be 0 to infinity. Note we put a parenthesis on the 0 because it doesn't actually touch 0. Okay, asymptote. So that's one of the new words. An asymptote is the line, again, that it gets close to but doesn't cross. So this is that blue line that I drew. So my asymptote in this case is 0 because it is crossing the y-axis at 0. So every exponential equation will have a horizontal asymptote that will be y equals and then wherever it's crossing the y-axis. I can also tell the y-intercept here is at 0, 1. So it's crossing my y-axis at 1. Couple things on the end behavior. As x is getting bigger, so as the x's are going this way, you can tell that the y values are also getting bigger. They're increasing. But if I go the other direction, let's say I decide to go this way instead, if I start plotting my x's this way, I can see as x goes to negative infinity, the y is actually heading towards 0. It won't cross the blue line. Okay, it's not going to cross that asymptote, and that asymptote is 0, so it's heading towards 0. Okay, so this equation 2 to the x, kind of one of the most basic exponential growth type of equations. And this key features, these are kind of the basic features to go off of for all the other ones. So I did want to show you the contrast of exponential growth, which is exponential decay. One of the things that makes this decay is that b value is a fraction. It's a value that's between 0 and 1. Okay? Notice that the red graph here, this curve, is coming down and it's decreasing. That's another reason that it's decay. You can also tell from the table, look at those y values. They are decreasing as the x values are increasing. A lot of the features are the same. The domain is still negative infinity to infinity. The range is still 0 to infinity, and my asymptote is still at 0. I've not had any vertical shifts to change that asymptote. One thing that is different is the y-intercept, and that has to do with this number out front. We have a stretch that's moving that y-intercept up to the 5. Notice on the end behaviors, they do switch a little bit compared to exponential growth. Notice as the x's are getting bigger, so as the x's go this way, look, that y is heading towards 0 again. But as x gets smaller, let's say I make it go the other direction, this way, okay, my y's are actually getting bigger. They're increasing. As I have negative values, those y's are growing. Okay, so you see a lot of similarities between the two. But the main difference is one of the graphs, exponential growth, goes up and exponential decay comes down. So let's go through how we would graph one on our own. So one of the things I want you to note is 3 to the x. That 3 to the x is telling me that this will be an exponential growth. So I already have in my head what that's going to look like. It's going to increase from left to right, and it's going to curve up. I know it's exponential growth because x is in the exponent, and the 3 is a b value that's greater than 1. Now, I know some of you might think that 3 is a stretch, but it's attached to the x, and x is in the exponent. So that's actually b to the x, which is telling us it's exponential growth. The 4 on the end, because it's negative, is telling me that the graph has a vertical shift of going down 4. So the only transformation happening on this one is going down 4. Because this graph has been shifted down 4, I now know my asymptote will be at -4. And so I'm going to come along here and I'm going to graph that asymptote. It will be a horizontal line that crosses the y-axis at -4. Notice that I made it a dotted line. Okay, that's going to be my boundary. So that's what our asymptotes lines will look like. We always start by drawing them. Now my y-intercept, we've learned earlier in the year, when we want to find a y-intercept, we have to substitute 0 in for x. So if I do 3 to the 0 minus 4, I can figure out that y value. Anything to the 0 is 1. So 1 minus 4 is -3. So I know I'm going to cross at -3. Now, we have not learned how to find x-intercepts for exponential equations by hand yet, so what we are going to do is just use Desmos. So if you click over here to our Desmos, we can type in our equation, and if I can click, I can verify that my y-intercept was at -3, and I can see my x-intercept is about 1.262. So at this point, we can still use Desmos to help us out and to kind of verify some points. So I'm going to estimate that's right here. Now, as I said before, this is exponential growth. So now that I got a couple points on there, I'm going to draw my curve. Okay? Now, the domain of every exponential function is -infinity to infinity. I can put in any number as a power. The range on this one, though, the answers that I get out, I can see it's not going to go past that -4 on the y. So I will put a parenthesis, -4 to infinity. Okay? My end behavior, as x is increasing, so as x is going to infinity, I can see as this graph is going to getting bigger and bigger and bigger x values, the y values are going up. So I know the y is going to infinity. Okay? If I go the other direction, as x's are getting smaller, I can see that the y values are heading towards that -4. So as x goes to -infinity, y is going to -4. Okay, let's try one last graph together. So this one, we have f of x equals 1/2 to the x plus 3. So I want you again to note this portion of it. That's telling me it's exponential because I have something to the x power. That 1/2 to the x is telling me that that will be exponential decay because 1/2 is between 0 and 1. So my b value is between 0 and 1. The plus 3 on the end is telling me that the graph just got moved up 3. So my transformations are up 3. My asymptote now has just got shifted up 3. So I know that my asymptote will be at y equals 3. So again, I'm going to come on here, I'm going to draw my dotted line for my asymptote. That's y equals 3. If I want to figure out my y-intercept, I can do 1/2 to the 0 plus 3. Again, anything to the 0 power is always 1. So 1 plus 3, that tells me that that is at 4. So I know it will cross at 4. Now, to get that x-intercept, we're going to go back to our Desmos, and I'm going to clear this one out, and we are going to type in parentheses, 1 divided by 2 to the let's see if we can And we'll put that to the x power and plus 3. So if I look at this one, will it ever cross the x-axis? No. Okay, but I can verify that that y-intercept is at 4, and I could also verify that the shape is exponential decay. Okay, so when I come back over to do my x-intercept on this one, I know that it will not have one. Okay, and you can kind of tell that. We drew that asymptote line there at 3, so there's no way it's going to get down there to cross that x-axis. So now I'm going to just take that shape, and I'm going to come down, and I'm going to curve it and draw it right along that y equals 3. So our domain, again, is always negative infinity to infinity. My range in this case, since it got to 3, I will say is 3 to infinity. Now the end behavior, as x's are going to infinity, so as these x's are getting bigger, it's heading to, the y values are heading to the number 3. Oops, let me put a little arrow there. And then if we go the other direction, is that if the x's are heading this way, I can see that the y values are actually going up. They're getting bigger. So if x goes to negative infinity, y is now going to positive infinity. Okay, so you're going to do a little bit of practice here with graphing, and this is the steps you're going to be taking for your key features, and you will be sketching some graphs.